Hello there. My name is Jacob Kaplan, and this is my video for Fermi 210 Dynamics. So, in this example, I'm walking until I collide with my amp, which is on a chair, and then I push that mass together. So, I weigh 61.23 kilograms, which is converted from my weight of 135 pounds. And then I'm walking at a speed of 1.12 meters per second, which I calculated by using the walking app on a previous take. And then the chair and the amp together weigh 30.5 pounds, which converted is 13.83 kilograms. And here is a video of the collision. And so what if we want to know how fast I'm going when moving my chair and amp? So here are our givens and assumptions. So mass 1, which is my mass, is 61.23 kilograms. The speed that I'm moving at is 1.12 meters per second. And the mass of the chair and the amp together is 13.83 kilograms. And also, we can assume that momentum is conserved since there are no outside forces acting on the system, and that this is an inelastic collision, since I moved the chair and the amp together as one collective mass after colliding. So how do we find the velocity after colliding? So here we can look at our inertia diagrams. So first, before the collision, I am moving by myself with my mass 1 at a velocity 1. And then after the collision, I am moving together with mass 2 at a new velocity v2. And so we can use the conservation of momentum equation, which states that m1u1 plus m2u2 is equal to m1v1 plus m2v2. Now the good news is that we can greatly simplify this equation. So since m2, the chair and the amp, are not moving before the collision, the second term on the left side can cancel out and be 0. And since this is an inelastic collision, both m1 and m2 are moving together as one collective mass. So then we can combine them together and then multiply them by v2. And so after multiplying together m1 and v1 and then dividing by our masses added together, we get a new speed of 0.91 meters per second, which makes sense as momentum is conserved, and with a higher mass, we need to be moving at a lower speed to make the numbers the same as the left side before colliding.